everybody. So I'll try to be quick so that we use in the best way this time we have. We have three parts in this presentation. In the first part, I will show how the Tanaza architecture is done and how it works. In the second part, we will see a real working demo. So I'll show you what we can actually do. And in the third part, we will talk about what we are going to do, what we're doing, and the ideas we have and what we want to do in the long term. So let's go to the first part. Let's talk about the Tanaza architecture. It's based on three big elements. The first one is the Tanaza web interface, which is the web application used in the web browser by the user. The second one is the Tanaza cloud infrastructure. And the third one is the Tanaza agent. The purpose is to allow the user to push configuration through the Tanaza web interface to the third-party access points. Some of them can have the original firmware, and some others can have a firmware provided by Tanaza with the agent inside. So some information about the agent. The agent is basically a very small piece of software with no intelligence about the specific models it's going to configure. It's just a packet deliverer. So it creates, as a client, a connection to the Tanaza cloud infrastructure. And after that, the Tanaza cloud infrastructure, when required, is able to talk to the single devices. It can ping them, can send configuration files, and anything we need to do. We can deploy the Tanaza agent on a host inside the local area network of the user, or right inside the access point itself. It really depends on the scenario. Sometimes the customer has 4 or 5 access points on the server, so that's enough. In other cases, some system integrators really want not to have a host where to deploy something. So in this situation, they prefer to flash access points. So
could you back up on that? When you say host, what do you, a laptop at someone's office? Or where is that actually residing?
Right. Can be both. Can be a server or can be a laptop. It really depends on the user scenario. Sometimes the user is a small business owner, so he will want to configure his devices only when he's resident in the network. So I'm thinking about the host as a laptop as a host. If he moves the host outside the network, he will not be able to configure, but the network still works. If we consider a different scenario, like let's say a system integrator, he will want to have the agent installed on a server. So in that case, the host will be a server. When we say
does the host need to be within the local subnet? Or?
Yeah, right. Yes, yes. We need a host per each local subnet. Otherwise. And the agent is written in Java, and we can install it now on basically on Windows, Linux, and Macintosh, so pretty everywhere. While this agent is written in C, and it's based on OpenWRT, actually. Let's go to the Tanaza web interface. We designed an interface having in mind the needs of the system integrators. So the idea is that it should be simple to do every kind of action. We don't want really pages to reload. So it's an application, it's not a website. It's based on Ajax. There is no Flash, so you can use it also on your iPhone, on your tablet. And the interface is really simple. So once you use that interface to send the new configuration to a device, what happens is that the new configuration is sent to the database of the Tanaza cloud infrastructure. And after that, there is an engine who will take care of that configuration and will apply it to the third-party devices. So the engine is divided in 2 parts. We have an upper part, which is, we call that vendor-independent part. It basically takes configurations and apply configurations. And then we have a lower part. We call that the connectors, and they are really the vendor-dependent part. So in the database, we have a configuration of the access point in what we call Tanaza generic access point model. So it's basically the set of parameters that can be applied to any access point, like SSID names, IP addresses, but with any particular specification related to the devices. When we want to apply a configuration to a specific device, the configuration passes through the connector, and so it's translated. Sometimes it's translated into a file which is sent through HTTP. In other situations, it's a list of SSH commands. It really depends on the device. Some devices are based on text files. Some other are based on binary files, sometimes encrypted in two different ways depending on the part. So we found really many, many different ways to do it. And the point is that we think that the need of the user is not to have every time a different configuration interface. The need of this started when I was, years ago, I was installing access points for my parents, then for my friends, and every time I had to use a TP-Link, then a D-Link, then a Netgear, all the times the interface was different. At one point, I remember I couldn't find the reset button, the reboot button inside the interface. So I said, why? Why don't they do something similar? And this was just like the seed of this idea that then came in the years. Something about technology. The upper part of this of the Tanaza cloud infrastructure is based on Java virtual machine, or on Java, sorry. The idea is that we can leverage the abstraction capabilities of Java to manage a complex problem and break it into smaller pieces. Then the lower part, the connectors, are just text files. They are written with a scripting language called Lua, which is an open source scripting language. Lua means moon in Portuguese. And the cool thing of this is that we can deploy new connectors without the need to recompile the engine, because we call the primitives directly through that. So the availability is really higher thanks to this. Something about the current capabilities we have. So we can deploy the Tanaza Agent on hosts with Windows, Linux, Macintosh. We can configure access point without the need to configure a VPN. We can embed the agent on some access point inside the firmware, actually only for Ubiquiti devices. Then we can add the access point, put the names, put them on the maps, apply single parameters or multiple access points parameters, like, let's say, a centralized SSID concept. At last, we just added the remote monitoring function for the Tanaza Flash devices. And I think in a couple of weeks, it will be also released for any device supporting SNMP. It's actually not being developed, it's actually being tested, so we're almost there. One thing I wanted to point out is that in the case we have the agent inside the access point, we have full control of the hardware. So we can provide a higher level user experience. For example, the devices flashed with Tanaza can be auto-detected. So we can connect 20 of them, and then they will pop up in the interface.